All right, this is APAB Calculus. We are doing midterm review, and this is multiple choice number 6, which is non-calculator. So we're given a limit as x approaches infinity, and then we're given this rational function. So there's a couple ways to approach this. This is classic L'Hopital's, because if you plug in infinity, you would get an infinitely large thing over something else infinitely large, right? And infinity over infinity is one of those indeterminate forms, right? So this is literally never the answer, right? Like the other indeterminate forms we've seen, 0 over 0 or 0 raised to the 0 or 0 infinity minus infinity. These are not ever the answer. So knowing that, I can go ahead and do L'Hopital's, right? And so L'Hopital's is a special thing we can do with limits that result in indeterminate forms where we can differentiate the top. So we don't use the quotient rule, we just differentiate the top function, and then we differentiate the bottom and get a 1 minus 8x. Now again, I plug in and I would get an infinity over an infinity, which is again never the answer. So I'm okay to do L'Hopital's again, right? And if I do that, I'm going to get a 2 over a negative 8. Now there's nowhere to plug in the infinities, so I just get a negative 1/4, and that's my answer. That's fine. There is also an Algebra 2 way. If you look at Algebra 2, section 8.2, we talk about horizontal asymptotes. So this is just another way to do the same problem, horizontal asymptotes. And you may remember that when we did the horizontal asymptotes of rational functions, if you had some like ax squared plus some stuff over some bx squared plus some stuff, if these degrees were the same, then the horizontal asymptote was the fraction of the leading coefficients. Well, based on that argument, the degrees of this thing are the same. The fraction of the leading coefficients would be a 1 over a negative 4, and sure enough, it's the same answer. So either way, you get B.